So today we are going to study about a new topic, footings. Definition: footings are structural members used to support columns and walls and to transmit and distribute their loads to the soil in such a way that the load bearing capacity of the soil is not exceeded. Excessive settlement, differential settlement, or rotation are prevented, and adequate safety against overturning or sliding is maintained. Types of footing. Wall footings. Wall footings are used to support structural walls that carry loads for other floors or to support non-structural walls. Isolated or single footings. These are used to support single columns. This is one of the most economical types of footings and is used when columns are spaced at relatively long distances. Combined footings usually support two columns or three columns not in a row. Combined footings are used when two columns are so close that single footings cannot be used, or when one column is located at or near a property line. Cantilever or strap footings. These consist of two single footings connected with a beam or a strap and support two single columns. This type replaces a combined footing and is more economical. Continuous footings. These support a row of three or more columns. They have limited width and continue under all columns. Rafted or mat foundation. These consist of one footing usually placed under the entire building area. They are used when soil bearing capacity is low. Column loads are heavy single footings and cannot be used. Piles are not used and differential settlement must be reduced. Pile caps are thick slabs used to tie a group of piles together to support and transmit column loads to the piles. Distribution of soil pressure. So we'll see how the soil pressure is being distributed. The soil pressure distribution in cohesionless soil and the soil pressure distribution in cohesive soil. Design considerations for a footing. Footings must be designed to carry the column loads and transmit them to the soil safely while satisfying code limitations. Bearing capacity of columns at their base. Dowel requirements. Development, length of bars, differential settlement. The area of footing can be determined from the actual external loads such that the allowable soil pressure is not exceeded. Area of footing is equal to total load into including self-weight divided by allowable soil pressure. Strength design requirements QU is equal to PU by area of footing. Footing usually support the following loads: dead loads from the substructure and superstructure, live load resulting from material or occupancy, weight of material used in backfilling, wind loads. General requirements for footing design. A site investigation is required to determine the chemical and physical properties of the soil. Determine the magnitude and distribution of loads from the superstructure. Establish the criteria and the tolerance for the total and differential settlements of the structure. Determine the most suitable and economic type of foundation. Determine the depth of the footings below the ground level and the method of excavation. Establish the allowable bearing pressure to be used in the design. Determine the pressure distribution beneath the footing based on its width. Perform a settlement analysis.